Hello everyone, welcome to Artistic Atom channel. I'm Fatima and this is part 3 of Mass Spectrometry session. In this session, we will be discussing isotopic peaks and also different tricks to understand how to solve the questions based on isotopic peaks easily. In this session, we will also be covering exam-oriented question, specifically MCQs, also the structured questions. Okay, so let's get started. So before going ahead and understanding the isotopic peak topic, let us first revise whatever we have learned in the previous session because that concept is literally important in understanding the isotopic peaks. In previous session, we have learned that mass spectrometer separates these molecular ions based on their mass to charge ratios. Okay, so when I talk about mass to charge ratio, it is nothing but the molar mass of that particular compound divided by the charge. When I talk about this charge, it is nothing but the number of electrons which were knocked off from that particular uh, molecule. Molecule or the compound. Okay, so usually since there is just a loss of one electron, this charge is always equivalent to 1. Hence always the mass to charge is equivalent to the mass of that particular compound. Now always remember that this is not going to be the case where you have more than one electrons getting lost from the main compound, because if there are more than one electron, then we have to calculate mass to charge ratio, and hence it will not be equivalent to the mass of that particular compound. Now, how exactly these molecular ions they formed? So we have our intact molecule. Okay, it undergoes ionization process and results in the formation of molecular ions. Since these molecular ions still have a lot of energy associated with them, they undergo further fragmentation and results in the formation of subsequent fragments. Now, other source from where we can get these subsequent fragment is the subsequent fragment itself. Okay, so when I talk about subsequent fragments, these are nothing but the further fragments formed after the molecular ions, and they are still in bigger size, so they can be further divided and they have a lot more energy associated with them. So in order to get rid of that particular energy, they undergo fragmentation and results in the formation of other subsequent fragments. This process takes place until the point when my fragment is not able to further divide into the smaller fragments. Also, there is another possibility that that particular fragment has lost whole energy. Since it is not left with much more energy, it will not undergo further fragmentation. So this is what we have learned in the previous session. Now once we have got all the fragments, it the mass spectrometer gives us this mass spectrum. Okay, where on the y-axis we have relative intensity and on the x-axis we have m by z value. Since this m by z value is equivalent to the mass, we sometimes write it as what mass of that particular compound. And here we get these peaks. These peaks represents the molecular ions along with the further fragmentations which are formed in the mass spectrometer. Now the highest peak, as you can see over here, this peak is the most intense peak in the in the mass spectrum, and this is called as what base peak. And we call this base peak as what the 100% formation of the most stable carbocations. Okay, so this is how actually the mass spectrum is obtained, and this is what we have learned in the previous session. So till now we have revised whatever we have learned in the previous session. Now let us understand why does one molecule give molecular ion peaks. Okay, why there are multiple peaks and that of the molecular ion. For this, let us take this condition. Okay, here is the mass spectrum and here is the condition. The condition is I am taking my molecular ion itself, okay, and I am taking its mass spectrum. So if I carried out the whole process, I can see that I just have one charged particle, that is the molecular ion itself. There is no other further fragments. But still, in the mass spectrum, I can observe that instead of showing just one peak, there is presence of other two peaks. Now my question is, from where we are getting these two peaks? Well, the answer to this is due to the isotopic peaks. What do you mean by isotopic peaks? Let us understand how they get formed in the mass spectrum. So, well, when we talk about an element, because we know that a compound consists of different atoms combined together chemically, we call it as what, a compound. So, inside that compound, what do we have? We have different atoms. Okay, so when we talk about these atoms can have different masses. Why? What could be the reason? Because these species having the different mass but the same atomic number, these species are called as what? Isotopes. Since they have different masses, it get detected in the mass spectrometer. And as they get detected, they results in the formation of what? Isotopic peak. Because the mass of the molecular ion differs from these peaks just by 1 or 2 units, depending upon the condition, it results in the formation of M plus 1 or M plus 2 peak. Okay, so if the mass is increased from in comparison with the molecular ion peak, then that particular just by 1 unit we call it as what? M plus 1 peak. If the mass is increased by 2 units, we call it as what? M plus 2 peak. So we have understood what could be the reason behind the formation of isotopic peaks or the multiple peaks that we observe along with the molecular ion. Now let us understand M and M plus 1 peaks. Okay, so here we are taking example of carbon. Carbon exists in three isotopes: carbon 12, carbon 13, and carbon 14. When we talk about carbon, the difference between three isotopes is that their abundance is different. So since their abundance is different, so the one which is more abundant will be formed in the more amount. Hence, the height of that peak will be more than that of the others. So I can see that carbon 12 is most abundant among all three. Hence, we will call the peak results in formation due to carbon 12 as what? M peak. Now, carbon 3 is approximately 1.1% in the nature. Hence, the other peak, which is formed due to the presence of carbon 13, we call it as what? M plus 1, because the molecular ion which is formed because of the carbon 13 will just have mass higher by 1 unit. So, we will call that particular peak as what? M plus 1. Now, when we talk about carbon 14, we can see that the mass is higher than 2 units. So this means there is probability of the formation of M plus 2 peak. But there is a slight change. This change is that since the abundance of this carbon 14 is very low, it is very low, it is low to such an extent that the mass spectrum cannot detect it. Hence, we just neglect this particular peak. Okay, it is not at all visible in the mass spectrum. The reason behind is because the abundance of this particular isotope is very less in the nature. So this is how actually we get the M and M plus 1 peak. M peak is due to the most abundant isotope. M plus 1 is due to the isotope which is just one mass higher than the uh, M peak. Okay, so this is how actually we get the spectrum for M and M plus 1 peak. So in conclusion, please remember that carbon gives only two isotopic peaks, that is M and M plus 1 peak. Now, if you look at this spectrum, I can see that the mass, this is my molecular ion peak and this is the other isotopic peak. But I can see that the mass is higher than that, or higher by 2 units, but we have discussed for 1 unit. So this means this is some other isotope, because there is no possibility of carbon 14. This means there is some other isotope which is present. So let us understand how do we get these M plus 2 peaks. So when we talk about M plus 2 peak, it cannot be explained by carbon. We know the reason also that we have discussed in the previous slide. Now M plus 2 peak can be due to the increase in mass by 2 units. So let us take the example of the elements which increase the mass by 2 units. So there are common contributors that you will study. First one is the chlorine, second one is the bromine. When we talk about chlorine, it has two isotopes, chlorine 35 and chlorine 37. The abundance of chlorine 35 is 75. So this will be most abundant and this will give me M peak. Okay, and this chlorine 37 is less in abundance, hence this will give me what? M plus 2 peaks. Why M plus 2? Because the molecular mass increased by 2 units. Now in the same way, here we have bromine. Okay, so in bromine we have two isotopes, bromine 79 and bromine 81. The natural abundance of both the elements, both the isotopes, is as follows. And you can see that their mass is also increased by 2 units. This means this one will give M peak and this one will give what? M plus 2 peak. So this is how actually we get the M plus 2 peak. Now, always remember, in case of halogens, you will not see M plus 1 peak or M plus 3 peak. The reason behind is this, because they do not have mass increase by 1 unit or 3 units. Instead, you will see M plus 2 or M plus 4, M plus 6, like this peaks, okay? So as you can see in this example, it is clear that we have understood that this peak could be due to presence of a halogen. Now let us understand why there is a difference in height, because in the previous slide only we have seen that in the mass spectrum we have two peaks. One was due to the molecular ion, another was due to the halogen isotope. But I can see that there is a difference in height. Well, that difference in height is due to the abundance of that particular isotope. Because if the isotope is more abundant, it will give the more taller peak. If the isotope is less abundant, the peak will be shorter. So this is the reason why we get the difference in the height of the molecular ion peak and its isotopic peak. Now let us understand uh, this height clearly, because when we talk about chlorine and bromine, they have a height ratio that is 3:1 and 1:1. This means if I have a spectrum where I can see that there is chlorine present, so due to chlorine, the molecular ion will be taller, and the this isotope 37, which will give M plus 2, will be shorter in height, and their difference in height will be approximately following 3:1 ratio. This means the M plus N peak will be 3 times higher than that of the M plus 2 peak, whereas in case of it is exactly equal in bromine. Now let us understand how do we get these ratios, height ratios. So let us understand how to calculate the isotopic ratio. Well, it consists of three simple steps. First one is to start writing their abundance. So firstly we will write it for what? Chlorine isotope. So when we write chlorine, these are the two isotope and this is their respective abundance. Now let us determine the highest common factor for 75 and 25. When we determine the highest common factor for these two numbers, the highest common factor that will come is at what? 25. Now let us divide both the abundance percentage by 25. So this is how we get the ratio, and this ratio is called as what? The isotopic ratio. This means the both the isotope will result in the unequal height of that particular peak. Now let us determine the isotopic ratio for bromine. So we will follow the same step. First we will write their abundance. Since we can see that their abundance is closely equivalent to 50, we will round them off, and this is what we get. Now the HCF for this value will be 50 only. So if we divide them, the ratio that we get at the end is 1:1. This means both the bromine will give equal height. Remember this because this will help in solving the questions. Now let us understand how to determine the number of molecular ion peaks in case of halogens, because you will be having questions based on this, that you will be provided with an alkyl halide compound and you have to determine how many molecular ion peaks it will result in the mass spectrum. So there is a trick to do this. The trick is this. Okay, so whenever you have a compound given, you just have to count the number of halogens present. So depending upon the number of halogens, you will directly follow this formula, that N plus 1. This means the number of molecular ion peaks will be always equivalent to the N plus 1 value, where N is the number of halogens present in the compound. So suppose if I have given you a compound consisting of 4 halogens and I'm asking you how many molecular ion peaks you will see in the spectrum, you you will say 5, that is n plus 1. So 4 plus 1 is equivalent to 5. Hence, you will say that in the spectrum, you will see 5 molecular ion peaks. Okay. So this is the trick. Remember this. This will surely help you in solving the questions. Now let us solve this question. Chlorine has two isotopes, chlorine 35 and chlorine 37. Assume that in the molecule, this is the molecular formula. There is only one hydrogen isotope and one carbon isotope. This means I don't have to consider the carbon and hydrogen isotope. Then I have to determine how many molecular ion peaks will be seen in its mass spectrum. This means carbon isotopic peaks and hydrogen isotopic peaks will not be given. So let us calculate. The trick is this, that is, you will follow this trick, that is the number of halogen present in the atom plus 1. So if we do this trick, we will see that there are 4 halogen present plus 1. This means the number of molecular ion peaks will be equivalent to 5. So this is the correct answer. So this is how you're going to use this trick to solve the questions. Now let us solve this question. So question is, bromine exists as two isotopes, bromine 79 and bromine 81, which are found almost in equal abundance. Which of the following statement is correct? So these statements are given. The statements are as follows. Bromine 79 is more reactive than bromine 81. And then other option is the mass spectrum of this compound has two molecular ion peaks. One is at 122 and another one is at what? 124. Remember, this data is going to help you. Can you see the difference? The mass of the molecular ion has increased by 2 units. This means yes, there is possibility of presence of what? Halogen. But we have to determine whether in detail whether this option could be the correct one. Let us check the other one also. So the atomic radius of bromine 79 is less than the atomic radius of 81, and the last option is the first ionization energy of bromine 79 is less than that of the first ionization energy of bromine 81. Well, when we talk about isotope, always remember that they have same chemical reactivity, they have same atomic radius. Why? Because their electron number is same. So since their electron number is same, they will have the exactly same size of their atom. And also, since they have the same size of their atom, there is no difference in the ionization energy. So remember that isotopes, they differ in mass, but their chemical properties are same. This means these all three options, that is this, they are reactive, they have different radius and different ionization, all three are incorrect. So if you follow elimination method, you are directly directed to the correct answer. But let us cross check whatever is the correct answer. So when we talk about these two peaks, we can see that there is a difference by 2 unit in their mass, which clearly indicates that it is due to bromine, and hence this particular statement is absolutely correct. Now let us solve another question. Which of the following statement about the mass spectrum of methyl bromide is correct? So here we have to determine the correct statement. So the first option, here are the options. Okay, I will not read it. Let us directly solve the question. Now in these options, there are 3 things that they are pointing to. First one is there is possibility of only one molecular ion peak. So firstly, we have to determine how many molecular ion peaks are there. So suppose if we are getting only one, this means we can eliminate these 2 options. If we are getting only 2, then we can delete these 2 options. So this means you can easily follow the elimination method. So firstly, we will determine the number of molecular ion peaks. So if we determine it, we have the formula n plus 1. So we can see that there is just one halogen present. So this means n will be 1. So if I calculate it, I will get the number of molecular ion peak as what? 2. So this means I can directly eliminate these 2 options, that is option A and option B. Now I have to check these 2 options. But in this, I can see that the question shows that there is height ratio of 3:1. And in other one we have equal size and 94 and 96 as their M by E value. It is very clear from the question itself that we can see there is presence of bromine, and bromine gives 1:1 ratio of height in their peak. This means they have exactly same height, whereas this 3:1 ratio is for what? Chlorine. So we can directly eliminate option C, and we are left with the correct option as what? Option D. Okay, and you can even cross check your answer whether the option D is correct or not, because if we calculate we can see that the difference in these two mass is just by 2 units, which is due to the bromine, and even you can calculate it in order to cross check. Okay, but still remember that trick is going to surely help you in order to determine the number of molecular ion peaks in case of halogens. Now let us solve this question. The question is a compound XF, and F is n times present in that particular compound, is a fluoride of another halogen. This means this F is clearly fluorine, whereas this X is the unknown halogen. And it is known that n is greater than 1. This means there are more than one fluorine atoms present in the compound. The highest M by E peak in the mass spectrum of XFN is assigned to the parent ion and appears as a single peak at M by E is equals to 222. So this means here they're giving hint. Okay, this means if I carry out the mass spectrum, I will just get one single peak. Let us first understand what is the meaning of single peak. When I say single peak, this means in the parent molecule there are no isotopes present. So this means X is not having any isotope, also fluorine is also not having any isotope. They have just one single abundant isotope present with them, which is there with the molecular ion. This means this step is absolutely correct. That is, these two atoms that do not have any isotope in the compound. But we have to determine the incorrect option out of all these four. So this means the C option is correct. Now let us check the other option. So we can see that when we talk about these other options, we can see that in option B, they have mentioned that the compound could contain bromine, and the D option is the compound is a fluoride of iodine. So let us check which halide will be present in the compound. So if we check the halide, we know that we have three halide other than fluorine. Okay, so these are chlorine, bromine, and iodine. When we talk about chlorine, we know that it gives two isotopic peaks, which is in the ratio of 3:1. This means chlorine is not there only in the option. Now let us check for bromine. So if we check for bromine, it also gives two isotopic peak, but in the question it was already mentioned that there is single peak. This means there is no possibility of bromine. So if there is no possibility of bromine, this means option B is incorrect. And if we talk about iodine, it gives only a single peak because it have only one abundant isotope. This means this option D is absolutely correct. Now, if so, here only we have got that this particular option is the incorrect one. But let us check the last option, that is option A. So if we do the calculation and determine the value of n, we get this value exactly equivalent to 5. This means this option was also correct. So this is how actually you're going to solve these questions. Now the next question is an organic molecule with molecular formula this is analyzed using mass spectrometry. Here we are going to just discuss the mass spectrum. We are not going to discuss the IR and 1H NMR spectrum. In further sessions, we will be discussing these two spectroscopy techniques as well. Now here the question is determine the relative molecular formula from the spectrum and account for the peak at M by Z29. So here they are asking you two things. First is to determine the molecular ion formula, sorry, mass, molecular and mass, and secondly you have to determine the peak. Now, when we talk about molecular mass, you can directly calculate it from what? The molecular formula given. And other technique to calculate is using the spectrum. So the highest MZ value is always your molecular ion peak. So you can see that it is at 44, and I can see that if I calculate it from the molecular formula, it is also 44. So you can follow any of the method to determine the molecular mass of the compound. Now, the next part in the question is to determine from where or what would be the fragment which is giving this peak in the spectrum. So let us do the calculation. So till now we have determined the relative molecular mass. Now let us determine what could be the possibility of this peak. Okay, from where we are getting this peak. So let us first draw this structure properly. So once we have drawn this structure properly, let us do the fragmentation. We have learned all the steps how to carry out fragmentation in the previous sessions. So please do check that, because once you have understood how to carry out the fragmentation, you will be able to solve most of the questions asked from the mass spectrum. So once we have carried out the fragmentation, you can check other possibilities also. I have just shown the main one. So if we carry out the fragmentation at this particular bond, we can see that these are the two species that we get. First is this radical, and this is the radical cation. And we know that in mass spectrum only the charged species they get detected, whereas the radical or the neutral species they get lost in the vacuum. So when we calculate the molecular mass of this particular radical cation, we get that it is equivalent to what? M by Z 29. So this is the fragment which is resulting in the formation of this particular peak in the mass spectrum. Now let us solve another question. Question 6 is compound P contains carbon, hydrogen and oxygen. So here we are not provided with the molecular formula. Okay, we are directly provided with what? The spectrum. So there is just a spectrum, no molecular formula. Now the mass spectrum of the compound P is shown above. Determine the relative formula mass. So this time we cannot use the molecular formula because the molecular formula is not given. You can use the other possibility, that is you can use the mass spectrum, check for the highest M by Z value. That value is nothing but the relative formula mass of that particular compound. And secondly, we have to determine what could be the fragment for this peak, that is M by Z is equals to 49. So we will directly follow what I have discussed just now, and we will see that the relative formula mass for P is equivalent to 60. Now let us determine what could be the reason for this peak. Well, since here we are not provided with the molecular formula, we cannot carry out the fragmentation. Then how you will answer this question? Well, you will directly write the possibility of the radical cations that can give this peak. So the possibilities also we have discussed in the last to last session, where I told you that for 45, there are two possibilities. First, it can be due to carboxylic radical cation or due to the secondary alcohol. In these two only, we get the M by Z value as what? 45. So always remember these values. I have given you all the tricks how and also the tables and the values. You can remember those values and directly solve these questions. So one of these two radical cation you can write in exam, you will get the full marks for this question. Can you see over here? Here I have mentioned how in case of secondary alcohol we get this peak, because this peak is this value M by Z value is the characteristic peak for secondary alcohol. Even in case of carboxylic acid they show peak at what? 45. So remember these values, these will help you in solving the questions. With this, we have completed our session. Thank you for watching. Do like, share, and subscribe to my channel, Artistic Atom. See you in the next session.